Foreshore Protection, leaders in the field of erosion control using grout-filled revetment mattress products, were given the task of designing, developing and testing a flexible armouring system to protect the seawalls surrounding Sydney's third runway project. Under the supervision of consultants Connor Wagner, strict design parameters involving design life, flexibility, weight, installation technique and cost effectiveness were provided and achieved through the creation of what is now known as our collapsible block mattress. The runway, located adjacent to Sydney's Kingston Airport, is built from sand ridged out of Botany Bay. In order to protect the extremities of the runway from the erosive forces generated by currents and wave action within the bay, a reinforced seawall had to be constructed. Temporary bund walls with spear pumps were constructed outside the wall location to allow both the wall and the mattress system to be constructed in the dry. To prevent scouring occurring underneath the wall, Foreshore Protection installed its collapsible block mattress on the seabed, extending out for a length of up to 15 metres. The design called for the system to withstand wave heights of up to 1.4 metres and wave periods of approximately 4 seconds. It was vital to create a strong connection between the wall and the protection system, and this was achieved by placing the mat underneath the footing pads of the wall, thereby utilising the wall mass to stabilise the mattress. The wall was constructed at a rate of approximately 45 linear metres per day, which created a need for up to 500 square metres of collapsible block mat to be placed each day to allow continuity. Approximately half a metre of fabric was left exposed on the seaward side of the wall to allow the main fabric sections to be stitched on. The main wall sections were then placed on the footing pads. Sand backfill behind the wall was compacted over the wall reinforcing straps to create a stable structure. Once the wall was in place, the seabed adjacent to the wall was compacted and levelled in preparation for placement of the fabric. The extremity of where the mattress is to be placed was angled down to lock the sand in behind the mattress. The fabric was then stitched to the mat exposed from under the levelling pad. Once attached, it was then spread out and positioned in readiness for injection with grout. Temporary dummy seams were then stitched in the mattress to allow pumping to be carried out in sections, as well as ensuring correct pressurisation and inflation. Meanwhile, the grout was ordered and delivered to the grout pump located adjacent to the wall. Grout consisted of a sand cement mix with a high water content. This ensures the correct flow characteristics necessary for an even flow inside the mattress. Injection begins by cutting a hole in the top layer and sliding the injection hose inside the 2 layers of the fabric, securing it with a burlap and holding it in place. The mattress then begins to fill, and the grout is transported to each block through the grout tubes located on the side of each block. The maximum thickness is set by way of internal restraining ties, which also act to reinforce the grout. The size and thickness of the blocks can be adjusted to suit the requirements of individual projects. With an expected design service life of 100 years, a heavy-duty polyester fabric was the ideal choice due to its inherent strength retention under ultraviolet and abrasive attack. Observed over a 1-hour period using time-lapse video, the speed of installation is clearly noticeable. Once the section is fully pressurized, the hose is removed and placed in the next section. The importance and delicate nature of this project call for 3 months of model tank testing and development in order to satisfy the authorities concerned. The benefits of the collapsible block mattress system over the traditional alternatives such as rock mattressing, riprap protection and other cumbersome flexible concrete systems resulted in approximately 32,000 square metres of mattress being installed on this project. The temporary dummy seams are removed and the process repeats itself. With quality assurance becoming an important factor in today's construction, extensive tests were carried out on both the fabric and the grout. Test samples were taken after every 40 metres of grout was delivered, and a target strength of 20 MPa was required to ensure that a strong, durable protection system was in place. With every 300 metres of mattress in place, the bung walls were removed and the sand used to fill the runway area. The hinges between the blocks allow the mattress to flex in any direction, and testing has proved that the grout within the connecting tubes actually cracks to allow up to 90 degrees rotation of the blocks along the hinge line without any adverse effect to the fabric. As a wholly owned Australian company with 20 years experience in this field, Foreshore Protection has carried out projects in the Middle East, America, Europe, Scandinavia, Asia, Pacific Islands, Brunei,